Hello students, in today's class we are going to discuss about the unit 1. Already we have discussed about the all the wind concepts, wind power production concepts, that is unit number 4 and 5. As already we have completed the unit number 4 and 5, today I am going to start the unit 1. And unit 1, so it is completely different from the unit 4 and 5. Unit 4 and 5 were dedicated for the wind applications, and today we are going to discuss about the solar applications. So from this unit, so remaining units are so based on the solar applications and the solar power productions, all the aspects related to the solar power production, so we are going to discuss. So from this and unit number 1 is introduction to solar PV. So PV means photovoltaics, so short form of PV, so short form of photovoltaic, so we write it as a PV. And so first, before starting to the power production, solar power production, so we should be knowing how it will be producing the so energy or the power from the solar. Basically solar PV means, so that is a equipment which convert the solar energy into the electrical power. So solar energy into the electrical energy. And solar energy means it is basically the so it is a solar light. Basically it is solar light means it is a so electromagnetic waves, whenever it falls on the solar PV, that PV cells, silicon cells, it converts that so solar so electromagnetic wave into the so electrical energy. So that is the basic technology. And now so coming to this, first we need to discuss about the basics of solar PV. So means, so unless we know the basics of solar PV, so it is not possible to analyze the so MPPT, maximum power tracking, or it is not possible to find out, or it is not possible to analyze the efficiency and all the remaining aspects. So first thing, so what we should do is we should understand the basics. So that is the basics of solar PV. And here already I have mentioned, so photovoltaic system is made up of several photovoltaic solar cells. So means PV system is a different, PV cells are the different. PV system means it is made up of several PV solar cells, means one small module if we buy, so it may be having several so cells in that. Normally each cell, it will be PV cell, each PV cell it will be having capacity to produce the 1 or 2 watt of power approximately. Normally in general, so in market whatever the PV modules are available, those solar cells are made for the 1 watt. So each means the meaning is, so if one module is having the 10 cells, so each cell is of 1 watt means, so we can conclude that that module is a 10 watt one. So that is the meaning of this. So each cell approximately it will be producing 1 or the 2 watt of power. And higher power output PV cells can be connected together to form the higher power modules. Means the higher power modules, so are we need to generate the 10 watts, 20 watts, 100 watts, 1 kilowatt, 100 kilowatt or megawatts of power means, so we are going to so connect these cells in series and the parallel connection, so that we can generate the higher power. So basically it is a cell 1 or the 2 watts, and then those will be connected in series, and then so we make the modules. And whenever we connect the modules in series, suppose each module is a 100 watt module, and then 100 watt module, 10 modules if we connect in series, then it becomes the 1 kilowatt. And if we consider the 1 kilowatt modules and 1 kilowatt modules, if we connect it in series, it becomes the 100 kilowatt. That is the meaning of this. In market, maximum power capacity of the each module is 1 kilowatt. So nowadays even the more capacity one are available, but in practical and the most of the places whatever we are using, so these modules, power PV modules or the PV systems, so it is made maximum for the 1 kilowatt. And if we want to install the 10 kilowatt means, so we can install the 10 modules in series. So 10 into 1 it becomes the 10 kilowatt. 100 means 100 modules we supposed to connect in series. That is the meaning of this. And it depends on the plant capacity also. So while choosing the, so how many number of modules are required, and depending on the need, we can connect the modules in series or parallel, and we can start generating the power. And then coming to the next point, so next point is solar PV system are usually consist of numerous solar arrays. Solar arrays means, so whenever we connect the modules in series, or whenever we place the modules one behind one in series or in parallel, so those we call it as the arrays. And here it is mentioned the same. Solar PV system means, so it will be consists of numerous solar arrays. Although modules are from the same manufacturers, are from the same materials, so it may be different manufacturers, different materials. So overall performance or overall efficiency or the characteristics, it based on the individual cell performance. So that is the meaning of the second paragraph. So in the last it is mentioned, so performance of the individual components means, basically if I consider a module, suppose if it is having some 100 PV cells, so then performance of that module directly it is not possible to analyze. Then we consider the performance of the each cell, then multiplied by the, so how many cells are there. So in that fashion we are going to check the performance, because the efficiency we cannot directly define for the modules. So it depends on the efficiency of the each cell, because each cell will be, means between the cells there will be a small space. So even as those spaces will be existing, so it is not directly possible to conclude, so this module is having this much of efficiency, like that. So what we do is, we are going to consider the cell efficiency, and depending on the cell efficiency we are going to find the module efficiency, and depending on the module efficiency we can find the solar array efficiency, and depending on the array efficiency we can find the efficiency of the entire solar plant. So, and apart from the solar PV module system, components comprises a battery charging controller, inverter, MPPT controller, and some low voltage switchgear components. Means, so if we want to find out the performance of the solar system, or if you want to find out the performance or the efficiency or reliability of the solar module, so not only the cells we should consider the all the components are existing in the solar system. Solar system means it will be having the PV modules, PV cells, it will be having the battery charge controller means, so we use to charge the battery in a efficient manner. So the system will be called as the charge controller. So unless we use the charge controller, it is not possible to get the better efficiency of the battery. So in order to get the better efficiency of the battery, or in order to enhance the life of the battery, we use the charge controller. So that is what it is given. So solar system, so if we want to find out the performance or efficiency of the solar system, so not only we should consider the solar modules, PV modules, but also we should consider the battery charge controller, inverter will be present. So inverter, basically we use it to convert the DC power into the AC power, because whatever the power generated by the solar is a DC type, so that we can charge the battery from that. And then always the grids, whatever the grids available in India, all are, almost all are, the 99% of the grids are the AC type, and whatever the transmission distribution which we are using are the AC type. So definitely, so and even our loads are of the AC type, as all the loads, transmission, distribution, everything is the AC. We should convert the generated DC power into the AC power. So definitely we require the inverter in the solar PV system. So that is what it is mentioned here. And the MPPT controller means maximum power tracking controllers. So definitely MPPT controllers are required to extract the more power at the any given condition. So sunshine may be more, or clouds may be there, or sunshine may be less. At any condition, so always our system should extract the more solar power. So our system should extract the more electrical power. So that is what the target. So in order to do that, so we should be having one separate system, so that we call it as the MPPT controller. And then definitely we require the switchgear components for the protection system, means protection of the equipment. So and even the overall performance or the efficiency, it depends on those low voltage switchgear components also. So that is what the meaning of this paragraph. And then presently in market, the power conditioning unit. So power conditioning unit consists of charge controller, inverter and MPPT controller. So meaning of this is, so in market, so we can't get the separate inverter, separate charge controller, or the separate MPPT. So for the solar system, so it will be having one power conditioning unit, means that is one single setup, and in that single setup all these three things will be embedded, means it will be interconnected one by one. So why it will be so, means, so if we buy the different components from the different manufacturers and if we try to install from our side, so performance and efficiency will be differing. Always there should be a coordination between the all the components which we have discussed in the previous. There should be a coordination between the solar panel and the charge controller. There should be a coordination between the charge controller and the battery. There should be a coordination between battery and the inverter, and then inverter and the grid. So interaction and the coordination should be there between the components. So and by that we can improve the efficiency of the entire system. So so in market, power conditioning units are existing and it is available, and power conditioning unit means it will be having the charge controller, inverter and MPPT. A balance of system includes components and equipment that converts DC supply from the solar PV module to the AC grid supply, means that BOS. So BOS means the entire setup. Entire setup is, that is a balance of system. Entire setup means that is a entire solar system, means from panel to the end inverter, that entire system we call it as the BOS. That is the balance of system. And then many system, so in many system the cost of BOS equipment can equal or exceed the cost of PV modules. So here there are two things are there. So if we consider the solar PV system, so solar PV system means it will be consisting of several PV modules, and each PV modules will be consisting of several PV cells, and all these things will be connected in series, and this will be fed to the charge controller, and charge controller will be charging the battery efficiently, and battery will be connected to the inverter, and inverter converts DC into the AC, and then if the AC is compatible with the grid, we can fed into the AC grid. And now all the components except this PV system or the PV modules, so we consider it as BOS, balance of system. So balance of system means here DC is available, so till we integrate with the AC grid, whatever the system comes, entire setup we call it as the BOS. That is what the meaning of that. And so you can go through the second paragraph. So in that, cost of BOS equipment can equal or exceed the cost of the PV modules. Means normally while purchasing or while discussing the PV modules, we discuss only about the PV cells. So we not used to discuss about the remaining system usually. So what is the meaning of that means? So this BOS system cost, so normally it will be equal or more than the cost of the PV modules. That is the meaning of that. So always whenever it comes to the performance, or whenever it comes to the efficiency, or whenever it comes to the cost, we should give the equal or more preference to the entire BOS system also, how much we are going to give the preference to the PV module. That is the meaning of this. So here when examining the cost of the PV modules, these costs do not include the cost of the BOS equipment. Means normally in the theories, whenever we start discussing or whenever you browse the Google, so they give only the cost of the solar PV modules, and remaining cost normally they don't discuss only, but entire setup. So if the solar PV cost is 1 lakh, then nearly 1 lakh cost only it will be involving for the BOS system or the BOS equipment. So that is what the meaning of this. And typically battery used in the solar PV system, so it cost modules is 20 to 30% of the total, and 70% is balance of the system in the BOS. Means in the BOS, so if we consider the cost of the BOS, in this 20 to 30% it accounts only for the battery. Battery is the higher cost one in the BOS, and remaining system it accounts for 70 to 80% of the total cost. That is the meaning of this. So always we should give more preference to the battery, charge controller, inverter and the grid. That is the meaning of that. So you can go through how much cost it is involving in the battery and the remaining system. So always we should not consider only the PV modules, we should consider the remaining setup also always. Apart from 50% of the BOS cost, it lot means it goes in the maintenance. So we are considering only the price of those modules. So here we are discussing only the cost of the each component. So apart from the cost, always the maintenance cost of this BOS, so it is nearly the 50%. So it is expense compared to the total cost. Means in the total cost, so overhead is let us assume we have installed the full solar system, and from the very first month or from the very first day only we should start the maintenance of all the equipments. So how much this maintenance cost comes is nearly the 50% of the BOS installation cost. So let us assume, so BOS installation, so it is a 10 lakh so of overall installation, then nearly 5 lakh maintenance cost will be coming. So over the year, so that is what the meaning. So always, so if you want to increase the profit or if you want to increase the efficiency, so then if we want to get the benefit from this system is always we should try to reduce the maintenance cost, and always we should try to extract the more power, that is the MPPT. So by using this soft techniques, so it is possible to get the more profit. And then by controlling the balance of system is BOS components, increase efficiency, then modernized solar PV system can be maintained. Means from this controlling of BOS system, it is possible to increase the efficiency and it is possible to modernize the PV system. And BOS components include the majority of the pieces which makes up roughly 10 to 50% of the solar purchasing. So that is what already we have discussed. So BOS cost, so it may go up to 50% and sometimes it can be 10% also. It depends on the, so how much we are going to store. So normally, so if you want to have a more backup, so means if you want to charge the battery more, then bigger size battery we should purchase. And if we are not storing the power directly, we are converting and we are feeding to the grid mains. So we are feeding to the grid mains. So then the cost will be less. So it varies roughly from 10 to 50%. So as per the statistics, solar PV modules in the world market is steadily growing at a rate of 30% per year. Means, so this installation of the solar plants or the solar overall installation in the world level, it is increasing so at a rate of 30% per year. So as it is increasing in a 30% is very high value. So as it is increasing 30%, we should give more preference to the performance of the solar performance, or the more preference to the solar performance, efficiency and the cost of the system, so that so we can interact more with this market. So what is the need of present is, so how much we are going to increase the performance, that much it is going to benefit us. And then, so as it is increasing in a huge manner, so 30%, so it is a need of present to discuss all these points. And then one more main thing is by using this solar we can reduce the fuel consumptions. So that is the petroleum products we can reduce, as it is a renewable. So whole world is going towards the solar and wind. So only the thing is we should improve the performance, and we should improve the efficiency, then the reliability, everything, so that we can get the more benefit of that. One of the hindrance factor which is existing is efficiency of the solar PV cells. In commercial market, cell efficiency is up to 18.3%. So here, so each cell it can be having the 18.3%, and this efficiency is not so constant. It depends on the material and the manufacturing company also. And nowadays, so we are getting in the market, even the 18.3% solar cells are available, and even whether it is a monocrystalline solar cells or the polycrystalline solar cells, depending on that efficiency and even depending on the manufacturer, efficiency will be differing. And now, so if we consider this as a efficiency, and we can't conclude the same efficiency for the solar module. So cells are having the 18.3% efficiency, but the solar module will be having the lesser efficiency, because each cell may be having the different efficiency, and there will be a spacing between the cells, small spacing, as we are connecting those cells in series manner. So all these accounts, so the overall solar module or the array efficiency will be lesser than that. So that is what it is mentioned there. Always in any of the documents they will be mentioning the solar cell efficiency. So whenever it comes to the practical, we should not consider the solar cell efficiency, we should consider the module's efficiency. So that is what it is mentioned there. The overall system efficiency includes the efficiency and performance of the entire components of the system, and also depends on the solar installations. Means overall efficiency means, so overall cell efficiency, then the module efficiency, charge controller efficiency, battery efficiency, inverter efficiency, so and etc. Whatever the switch gear equipments, components we are going to use, so all those accounts. So and then how to improve the efficiency means, we should use the MPPT. So by using the MPPT, so efficiency of the MPPT is normally 98 to 99%. So any of the MPPT technique we can use, any of the circuit we can use, always the MPPT will be having very near to the 100% efficiency. So by using the MPPTs, it is possible to improve the efficiency of the solar system. That is what it is mentioned here. So in the tomorrow's class or in the next class, we are going to discuss about the different MPPT techniques which are available and how to improve the efficiency of the solar system and all. And now this is about the components of the solar PV, or the basics of the solar PV. In basics of solar PV, we have discussed about so how much each cell, so each PV can produce power, and how this will be interconnected in series and parallel fashion. So and how much is the capacity of the each PV module, and then we have discussed about the efficiency and performance, how it will be different dependent on the materials manufacturers, and then overall efficiency or overall system, solar system means which all components will be existing, that we have discussed. And then we have discussed about the difference between the BOS and the this solar array and the BOS, and how the cost will be varying, and we have discussed about the cost of BOS and the cost of the solar system, and then we have discussed about the maintenance cost, and we have discussed about the how the BOS cost depend on the battery sizing or the battery capacity, so that we have discussed. And then how the solar market in the worldwide it is increasing, so 30% growth is there, so that we have discussed. And then here we have discussed about the efficiency of the cell is, at present it is a 18.3. so why we should not consider the 18.3 whenever it comes to the entire system, that we have discussed. And the overall system efficiency, how it will be varying, and what all we should consider, that we have discussed. And the need of MPPT. So need of MPPT means whatever the previous points we have discussed, so all the problems are existing. So in order to improve the efficiency, or in order to overcome those problems, we should use the MPPT, and MPPT efficiency always it will be 98 to 99%, that is mentioned here. And then second concept here is, that is the PV module performance measurements, so that we should discuss now. So performance means each and every components and the installation type, and then maintenance, everything we should consider into so picture. So then only it is possible to find out the performance, or then only it is possible to calculate the figures, how much efficiency it is having, how much power it can produce, all those things. Then here first point is peak watt rating is the key performance measurement of the so PV module. So that is the peak watt rating means, so I am having a solar panel. So let us assume I will consider so the ideal condition, so ideal sunshine, so this much of sunshine will be available, and if that much sunshine is available, it will be producing the maximum power. That maximum power, it will be called as the peak watt rating. So that will be mentioned by W suffix P. So W suffix P will be called as the peak watt rating. So always, so it will be mentioned, so peak watt rating, so in the models, but we should not consider that peak watt models, because they, so those are dependent on the laboratory conditions. So that is what it is there in the next line. So peak watt rating is determined by measuring the maximum power of the solar PV module under the laboratory standard test conditions. Standard test condition means STC. So always that is the ideal one. Ideal means, so in the laboratory conditions, so always it will be generating the more power. That is what the WP, but these conditions related to maximum power of solar module are not practical. So already we have discussed, so laboratory conditions are the ideal one, but practically whenever we place under the sunshine, so it varies, so it will be definitely, it will be lesser than that. So then what we should consider is, that is nominal operating cell temperature reading. So nominal operating cell temperature means, so outside whenever we keep the solar modules, so outside some temperature will be there. Normally, so we consider the 25 degrees Celsius, and outside means laboratory conditions means 23 to 25 degrees Celsius. Outside it will be 35, 45, sometimes even the 50 degrees Celsius. So in that condition, so we should test the cell, and that we can consider as the peak watt. And then in reality, both the methods, that is the STC or the NOCT. STC means standard test condition, NOCT means nominal operating cell temperature technique. Both this will not be giving the accurate values. Means, so either the method is designed to indicate the performance of the solar module under the realistic operating conditions. So then how to find out this means, so we should keep it in real, so at some place, and then so entire day how much, so during the low sunshine how it performs, and during the high sunshine how it performs, during the evening time, during the cloudy time. So all the different conditions we should consider, and then ambient temperature with the, so ambient temperature, how much it is going to produce, that we can consider as the performance. That is what it is given here. Another method is to consider the whole day rather than peak sunshine hours, and it is based on the some of the factors like light levels, ambient temperature, and the air mass, and also based on the particular applications. Means this performance, it depends on the light level, means how much sunshine is available. It depends on the ambient temperature. So if the temperature is low, even though sunshine is more, it will be producing the lesser power, or it will be extracting the lesser power. And then the air mass also, it is also crucial point. And also it depends on the particular application, for which applications, for battery charging we are using, or directly we are feeding, or how much load is connected to that system. All these factors comes into picture. So all these will be affecting the overall performance of the system. And then solar arrays can provide specific amount of electricity under certain conditions. In order to determine the array performance, following factors are to be considered. Means till now we were discussing about the performance of the entire system or performance of the PV modules, and now we are discussing about the solar arrays. Solar arrays means if it is a 1 megawatt plant, means some 5-6 arrays may be there, and each arrays may be having hundreds of solar modules. So that we call it as the arrays. And in order to check the performance of the arrays, so these 4 factors are to be considered. So that is, first one is characterization of the solar cell electrical performance, means that is the cell performance, how much efficiency each cell is having. So that depends on the type of material and the manufacturer. So means first thing is we should consider the cell performance, and the second is degradation factors related to array design. Means it depends on the array design, how we are placing the arrays, at what distance we are placing. So all these designs comes into picture. So that is the degradation factors. Means if we keep the arrays very close to each other, then the shadows may fall on each other. So those kind of conditions and the inappropriate designs, all those things we can consider it as a degradation factors related to solar design. Then the third point is assembly, then the conversion of environmental conditions into solar cell operating temperatures. Means even the environmental conditions, so also we should consider in order to check the performance of the solar in order to check the performance of the solar arrays. And then the last is array power output capability. The following performance criteria determines the amount of PV output. Means array output capability also we should take into consideration in order to find out the solar array performance. And depending on the solar array power output, so it is possible to find out the amount of PV output, means entire plant output we can find out if we find out the solar array output. Means one array is having the some particular percentage of efficiency, and one array performance if we find out remaining arrays and the entire plant setup performance we can find out. That is the meaning of this. So in order to find out the solar array performance, all these 4 points are to be considered. One is a cell performance, second is a degradation factors related to array design, third one is environmental considerations, and the last one is array power capability. And now these are some key factors. That is the power output. Power output is represented in watts. Means some different notations are the different factors which we use to find out the overall performance are. So these one. So one is the power output. Power output is represented in watts. So already you are knowing. So we used to represent power in watts, and it is the power available in charge controller or the regulator, specified either as the peak power or average power produced during one day. Means power output means it is a charge controller output. Means here the second component in the system is the charge controller, and how much output we are going to get from the charge controller, that we should consider. And in a day how much overall average or the peak power we are going to get from the charge controller, that we should consider as the power output. And the energy output indicates the amount of energy produced during a certain period of time, and it is represented in watt hour per meter square. So here, it is energy output means it is not only the watt hour but also with respect to the area. Means if I consider 1 meter square area, or if I consider 1 acres of land, or we can consider the half acres or guntas, so how much energy so we can extract from that place at a particular time, per day or 2 days or per week, per month or per year. So related to that, so we can use the term energy output, and energy output unit as watt hours per meter square. Means with respect to area we are going to define the energy output. And next is conversion efficiency. Conversion efficiency means, so here first is, so solar power we converted into electrical power, so there one conversion happens. And then so here, so we modify the DC and then we charge the battery, there another conversion. And the inverter converts that DC into the AC, that is also conversion. So all this conversion efficiency are to be considered. And conversion efficiency means it is defined as the energy output from arrays to the energy input from sun. Means how much so efficiency that solar array is having. Means input is solar sun, so means how much sunshine we get from the, or how much irradiation we get from the sun, and the output is how much output we are going to get it from the arrays. So that percentage we call it as the conversion efficiency, and it also refers as the power efficiency, and it is equal to power output from the array to power input from the sun. And typically it is having a unit of watt, and the energy typical unit is watt hours. So in all these considerations, and here some standards are mentioned here. So that is balance of system, that is a BOS, and applicable standards. Means if we want to find out the performance, so we should be having some standards or the reference, then only we can compare the performance of the systems installed. So otherwise it is not possible to check the performance of the system properly. So and then, so we should be having some standards for the installation and for the erection, for everything, for each and everything. So which kind of inverter we should use means, so we should be knowing the standards, and which kind of charge controller we should use means, so that standard also we should be knowing. Related to that, some standards are available, all those standards are mentioned in the table. And here which are all the standards available means, IEEE standards are available, then the IEC standards are available. IEC means International Electrotechnical Commission. Then ASTM standards are available, that is AMO spectrum, and the UL standards also available, that is Underwriters Laboratories. So these are the different agencies which they have tested all the components, and they have mentioned the standards. And then coming to this table, then PV modules testing and certifications, we can do it from that certifications we can cross check with the UL standards, that is the UL 1703, or IEC standards 61125 or 61646 and 61730 and 790, or UL standard also it is available, that is 8703. All this total 5 standards are there, that is related to the solar module testing and certification. So always whenever we install, we should check for this certification standards, or the certification whatever they mention in the specification with the standards. So and then second is mounting system. For the mounting system we should refer to the UL 1703 standards. UL means Underwriters Laboratories. And for tracking system I will explain in the next slide. For tracking system we can use the standards of UL 9703, and combiner box we can use the UL 1741, and for inverter also we can use the UL 1741 or the IEC 62109, and for batteries UL 1989 or UL 2054 or UL 2580 or UL 1973. These are the standards available for the PV modules, mounting system, tracking system, combiner box, inverters and the batteries. And by referring to these standards, so we can install the solar system properly, or while the erection and the installation time we can go through all these standards, and we should follow those standards. And then coming to mounting structures, so in the previous table it was mentioned here. So second is mounting system, and coming to the mounting system or the mounting structure, so always we should consider these points, means common made mistakes in the selection of mounting structures are, means normally, so which kind of mistakes we do are, that is the durability of the system or the durability of the design, tilt angle, orientation, then the array shading, that is a PV array shading. Unless we consider this, it is not possible to do the proper mounting structure. Means if we want to mount the, or if you want to use the proper mounting structure, means all these 4 points are to be considered. Means we should be knowing the durability of the design, and we should be knowing the tilt angle, we should be knowing the orientation, and we should be knowing the PV array shading. And now coming to the first, tilt angle. So tilt angle means, so we should mechanism to the solar modules, so it means to the entire panel, so that whenever the sun moves from, means sun, so from the morning to evening, so from east to west it will be moving. So when sun is moving from east to west, always we should keep the solar module in perpendicular to the sun. So then only we can extract the more power. So that is related to this tilt angle mechanisms are there. So if we don't use the mechanism, so in the ideal condition we will be tilting and we will be keeping the modules. And then, so even the 365 days every month, even the sun path will be getting changed. So one is daily, so sun from east to west it will be moving, and then another is, so throughout the year path of the sun will be getting changed. So this tilting angle is the very important crucial point to extract the more power or to increase the performance. So always whenever we consider the mounting structure, we should consider the tilt angle as the, so very important point. And then similarly the, so that last point, that is the PV array shading, also very important one. So if we keep the solar arrays very close to each other, then the shading, so shadows of one array it can fall on the another array, and if we increase the height of some arrays and some are at the lower height, then also those shadows may trouble and it may decrease the overall performance, and overall efficiency may get decreased. So we should take the consideration of the solar PV array shading also, and if we consider all these 4 points, it is possible to so make the proper mounting structure which can improve the performance or which can give the more efficiency. And in market for the mounting structure, some tools also available, and common tools which are available in market are SunPath, then the Ecotech, then Celestial Light, so etc. All these tools are available to find out the tilt angle, orientation, and to avoid the solar array shadows and to improve the design. So some softwares are available or some tools are available. Those are these tools: SunPath, Ecotech, and Celestial Light. And another point is, for solar array installation with multiple rows, shading D-rate factor should account for losses that may occur when row shadows at the adjacent roads. Already I have discussed about that solar array shadows means whenever we consider the overall performance, even we should consider those this point into consideration. And then the next is power conditioners. Power conditioners means in the off-grid inverter in a battery-based PV system, it is important to review the efficiency and cell power consumption of the inverter along with the capacity, power quality and surge rating. Generally, inverter is normally sized to support the load, power factor and surge. Here normally if we are selecting the inverter means always we should consider the load. Depending on the load we should select the size and then the power factor and the surge. Power conditioning unit already we have discussed. Power conditioning unit means it will be having the inverter, MPPT and the charge controller. That entire setup we call it as the power conditioner. So in that main component is the inverter, and how to select the size of the inverter means we should consider the load, power factor and the surge. For the efficient operation of inverter, so it should have low self consumption to increase the battery life. So means if it is having the low self consumption, so we can increase the battery life. And high self consumption inverter, so continuously means if it is having the high self consumption means it will be draining the battery and the we get as a draining the battery, so lower backup power will be available and it will be decreasing, and it will be increasing the number of cycles and it will be decreasing the overall battery life. And further, as the efficiency of the inverter changes with respect to the load, it is a good practice to design the load on average efficiency rather than the peak efficiency. Means, so overall system efficiency, it depends on the load also, and then good practice is designing the load on the average efficiency rather than the peak efficiency. Means always we should consider the average efficiency as a key factor to improve the overall efficiency rather than considering the peak efficiency. In a typical inverter, the peak efficiency is mostly between the 20 to 30% of the total capacity. And in tomorrow's class, so I will discuss about the MPPT means continuation of this. So hope you have understood all the concepts which we have discussed in today's